Hi, welcome to This is My Architecture. I am Abhishek from AWS, and with me today I have Sarat from Intellect Design. Welcome, Sarat.
Thanks, Abhishek. How are you?
Great. So, Sarat, tell me about Intellect Design.
Intellect Design is a fintech and insurtech company. We provide different softwares for banking organization, insurance carriers, and risk and treasury organizations. So our job is to make the customer experience delightful.
Fantastic. And we are going to talk about one of your products today.
That's
right?
correct, yeah.
So, what does the product do?
So Intellect Fabric Data Service is the product what we're talking. So the idea is that the challenge what we have in the current insurance world is that you got multiple sources of data in different forms and places. Okay, so the Fabric Data Platform is a big data platform, which actually is the world's largest insurance carriers data sources, and it can actually provide data on different entities or corporations or persons of that sort. So we got the Fabric Data Platform currently already have built in 2,000 data sources, and what we provide is for the insurance carriers or the underwriters, where they can search, they can match, aggregate, triangulate the data, and then provide a particular entity score on a risk analysis basis.
I see. So, you're basically going through all sorts of data which is out there,
Yep.
finding insights into it, basis that building profiles for individuals,
Yep.
and then passing it on to your clients, which are primarily insurance providers,
That's correct.
who are able to take better business decisions basis those inputs.
Absolutely.
Right?
Yeah.
Sounds fantastic. So, take us through how you built the product.
So we got three different types of data sources. I mean, one is that we actually go and crawl different data sources like your social media, or it could be wellness, or it could be regulatory and company related data. And the second thing what we do is we also connect to the premium connectors. Those connectors provide a lot of crucial data where it's already processed data of that sort. And the third is basing on different carriers, the tier 1, tier 2, basing on their requirements, we create data connectors and we actually customize that for them. So in the first case where we got multiple data sources, all of that particular data actually is passing on to the ELB. And the ELB, basing on the number of data sources we crawl or we connect to the premium, it fans out into multiple managed services of the sort. And once the ELB actually does it, it actually pushes the entire thing onto the Kubernetes cluster, which has got multiple microservices within itself.
So, these microservices are essentially what are consuming these events that are coming. So, what sort of scale are we talking about here?
Yep. So the Kubernetes cluster at any point of time, actually, when you crawl those multiple data sources, has got 1 to 2 million messages at any point of time, which it processes.
Quite a bit.
Yeah, it has got multiple microservices. It could be a crawler service, JSON mapper, it could be dedupe service. All of that will be actually working within the Kubernetes cluster, and it actually pushes the data into the MQ because of different latency factors what it has. And once the process data is there, I mean, actually the MQ process data, once it's gone through the pipeline, data pipeline, where our machine learning algorithms uses Jupyter notebooks, we cleanse the data, we triangulate, at the same time we do contextual analysis and sentiment analysis. The process data is the one which actually gets pushed onto your Mongo Atlas.
Interesting. So, you basically have different microservices here, and you've loosely coupled them using Amazon MQ. That's great, actually, and you're using machine learning as part of your setup as well to gain much more insights into it. That's great. Interesting choice of database I see here. So,
Yeah.
what led to that design?
So, around 3 years back when we were doing the product engineering, I think we were using MongoDB on EC2 instances.
I see.
The overhead of using MongoDB on EC2 is that you need to maintain the snapshots, backups, archive it, and you need to follow the regulatory guidelines. At the same time, you have to keep up with the versioning, right? I think that's where a lot of our operations team have been busy with that. So while we were engineering with the MongoDB team, I think we found out there's a beautiful solution with MongoDB, which is hosted on AWS, where we can do the VPC peering and connect it to your Kubernetes cluster.
Fantastic. So, essentially this is running on AWS.
That's correct.
But because you're using VPC peering, so you have taken security into account here.
Yep.
The calls don't have to go over the internet. They're still, everything remains within AWS itself.
That's correct.
Great. I see you're using RDS and Radius here as well.
Yep.
Tell us a bit about what they are used for.
Yeah, that's the most important thing where our consumers are there. We got different underwriters, we got different agents, policy agents, or it could be insurance carriers.
So these are your clients basically.
Exactly.
Yes.
So what they do is they're the ones which connect to our Kubernetes cluster through the Kong API gateway.
Okay.
And the Kong API gateway uses RDS, which is Postgres RDS.
Okay.
And all the authentication happens to the key clock, which is also a microservice which is sitting in Kubernetes cluster.
Okay.
and it also connects to the RDS. So at any point of time, let's say you got 100 underwriters calling in for multiple reports, you would probably need around 100 odd key clock services running and processing the data. So the beauty about it is that Kubernetes provides the pod level auto scaling, while RDS provides the managed service from the Postgres. The Amazon provides the auto scaling on that one.
Fantastic. So you're able to scale at the app level, you're able to scale at the database level as well. And what role does Redis play here?
Redis, what it does is it uses we use it for the cache management.
Okay.
All the user session management is done by Redis. So within the Kubernetes cluster, we got close to 200 microservices.
Okay.
All of these microservices need to talk to different RDS. It could be talking to API gateway of the sort. So I think Redis is where, you got scale at which we can actually, number of sessions can be managed using the
Fantastic, fantastic. So I think this is great. It's a great product. It's solving a critical issue out there and all. So what's next?
Yeah. So as I was telling you, the core philosophy for us is going to be either self-healing has to be good, it has to be managed service or serverless. That brings that, when we adopted K8s around 2 years back, it was still running K8s over EC2. The managed worker nodes, managed nodes of the sort, you still have the overhead of managing them, right? And you still have the versioning to be done. The next bet for us is to move that into EKS. I think that will help us to remove the management overhead of running the K8s cluster. That's one. And the second important thing is we got Jupyter notebooks running on microservices or EC2 instances. I think that's something what we wanted to leverage AWS SageMaker so that you can actually, our data scientists can have access to different algorithms which are provided as part of the SageMaker. At the same time, it can be cost effective for us. The other important thing is MongoDB Atlas. I think we can start looking at DocumentDB, how it would help us to amend the whole solution and make it more AWS VPC specific traffic.
Great. So I think there's a fairly strong theme which is coming out of it. You want to focus more and more on your product, your
That's
core
correct.
features,
Yep.
and want to leave, offload the overhead of managing the infra onto us.
Yeah,
Right.
that's correct.
This is great. This is very useful. A lot of learnings out of it. Thank you very much for coming today and sharing your architecture with us.
Thanks, Abhishek, for having you.
Sure. And thank you very much for watching. This is my architecture.